Students, today in this video we'll see some basic concepts related to curve tracing. Okay, now for curve tracing, the curves, they are divided into 5 different types. We'll see those types. The first one, curves which are given by Cartesian equations in x and y and which are explicit relations. Like we can see it's y square is equal to 2a minus x upon x cube. That is, the dependent variable y, it is expressed directly in terms of the independent variable, which we call as the explicit relations. Then we have the curves given by Cartesian equations in x and y, which are implicit relations. That is, the dependent variable is not expressed directly in terms of the independent variable. We can see x square plus 2xy plus y square is equal to 0. Then the third one, the curves which are given by the polar equations in terms of r and theta. Okay. Then the next one, curves given by the polar equations of the type r is equal to a sine n theta and r is equal to a cos n theta. These curves are known as the rose curves. That is, if you have the equations of the curve like r is equal to a sine n theta and r is equal to a cos of n theta, either of these, then the curves are known as the rose curves. Then the last one, the curves which are given by the parametric equations. Now we'll see some few basic definitions for the curves. The first one, convex upwards. You can see a curve here. We have, this is the curve, this is a point A and we have a tangent at point A. What does the definition say? If the portion of the curve on both sides of A lies below the tangent at A, that is this side and this portion, it lies below the tangent at A, then the curve is convex upwards or concave downwards. Okay. Then next we have convex downwards. Here also you can see this curve, we have a tangent at the point A. The definition says if the portion of the curve on both sides of A, that is this portion and this portion, lies above the tangent at A, then the curve is convex downwards or concave upwards. See, if the portion of this curve on both sides of A, it lies above the tangent at this point A, this curve is called as convex downwards or concave upwards. Then we have point of inflection. Okay, what is this point? The point that separates the convex part of a continuous curve from the concave part is called the point of inflection of the curve. Now you can see here in this part, this point A, it is the point of inflection. It is separating the convex and the concave part of the curve. Further, at the point of inflection, the tangent line, if it exists, cuts the curve because on one side the curve lies below the tangent and on the other side it lies above it. Now this tangent, this part of the curve lies above the tangent, this part of the curve lies below the tangent. Okay. So at the point of inflection, the tangent line, if it exists, cuts the curve. So this tangent line, it is cutting the curve at the point A. Okay. And this point A, it is called as the point of inflection because it's separating the concave and the convex part of the curve. Okay. Then we have the multiple point. What is a multiple point? A point through which more than one branches of the curve pass is called a multiple point of the curve. Okay. Now a point on the curve, it is called a double point if two branches of the curve pass through it. If three branches of a curve pass through a point, then it is known as the triple point. And if R branches pass through a point, then such point is known as multiple point of order R. Then we have the node. You can see the figure. We have this curve, a double point. Double point, that is two branches of the curve pass through the point. You can see here. This is one branch and this is the other branch. So this point, a double point, it is called a node if branches of the curve passing through it are real and the tangents at the point of intersection are real and distinct. You can see here, this is the double point because two branches of the curve pass through this point. The branches of the curve are real. At this point of intersect, the tangents, they are real and distinct because we have two different tangents here at this point. So such a point, it is known as the node. Next comes the cusp. Now you can see here again, this is a curve and we have got a tangent at this point. A double point is called the cusp if two branches of the curve have a common tangent at that point. Now this point P, it is a double point because two branches of the curve are passing through this point. But what we have here, we have a common tangent at this point. Then this is known as the cusp. Okay. In case of node, two branches of the curve pass through the point, but we have distinct and real tangents. That is, we have two different tangents at this point. So it is known as node. And for cusp, we have a common tangent for both the branches. It is known as the cusp. And last comes the isolated point or conjugate point. A point P, it is called isolated point if the coordinates of P satisfy equation of the curve but branches do not pass through P. Now you can see the point P here. This is the curve. Now the coordinates of point P, they'll satisfy the equation of this curve, but the curve, it is not passing through the point P. If there exists such a point, then it is known as the isolated point or conjugate point. These were some of the basic concepts related to tracing of curves. Thank you.